Good afternoon. This is Algebra, section 10-1, simplifying radical expressions. All right, now this is my first time doing this online video stuff, and it's not easy for me, so don't laugh. Okay, if you see me going over here like this, that's where my book is, my online text, that's what I'm looking at. If you see me looking down like that, that's where the tablet is, okay? So that's this right here. So, simplifying radical expressions. A radical expression looks like this. Okay? So, there are two parts to it. This is one part. This is called the radical sign. All right? And this guy is the second part, and this one is called a radicand. Okay? I know some of you have asked questions at times about what's a radicand or what's a radical sign. A radical sign is a square root sign. Okay, so the first property we're going to go over here is called the product property of square roots. Also, I apologize for my writing on this tablet. It's not easy. It's just not easy. Okay. Basically, the product property of square roots says this. If you have the square root of a plus b, or a times b, all right, what that equals is the square root of a times the square root of b. So, for example, if you had the square root of 100, okay, this is the square root of 10 times the square root of 10. Okay? So what's that get you? Well, whenever you multiply square roots by the same thing, you end up with just the radicand that's underneath, like that. Okay, so I'm going to shift the page down a little bit. So let's do example 1 on page 528. Oh, something I did forget. The purpose of these videos that I'm going to be making is to substitute for my lectures, okay? And what that means is that I expect you to have your journal out and writing these down as I'm going over them, rather than just sitting there, staring off into space with drool coming out of the corner of your mouth and listening to me drone on. You need to take an active part in this. So have your journals, sit down, write this down in your journal as I'm going through it. Same thing as in class. If it's in my book, if it's in my journal, it should be in yours. All right. That being said, let's continue on with the example. Okay, so example 1 says this. Simplify the square root of 90. All right, and you're like, Gack, I don't know the square root of 90. Well, there is a thing to come to your rescue. And we all remember prime factorization, right? Yay, prime factorization. So we can break 90 into 2 and 45. We can break 45 down into 9 and 5. And we can break 9 down into 3 and 3. Thus, we have 2 times 3 times 3 times 5. So going back over here, the square root of 90 is equal to the square root of 2 times 3 times 3 times 5. Okay? Well, this you can break out as the square root of 3 squared times the square root of 2 times 5. Okay? So what that equals is the square root of 3 squared is 3 times the square root of 10. And voila. That's the answer to example 1. Okay, next we're going to go over something that's a different property of square roots. And it's a little confusing to some people because it has to do with what you end up with once you take the square root of something. So let's take the square root here of x squared. Okay? So the square root of x squared is equal to x, right? Duh. Well, what if x is equal to -2? Well, then we have the square root of x squared. Does that equal x? Well, let's find out. So we take the square root of -2 squared. We want to know if that is equal to x. Or in this case, does it equal -2? Okay, well, -2 squared is 4. Okay, so the square root of 4, is that equal to -2? All right. Well, the square root of +4 is 2. And that does not equal -2. So what this means then is this. You have to use absolute value signs around your root to force it into the positive realm. So the correct way of writing this would be the square root of x squared is equal to the absolute value of x. Okay? Now, what about the square root of x cubed, x to the third power? Okay? Well, this is the square root of x squared times x. Yes? So what this means is the square root of x squared is the absolute value of x times the square root of x. This is the x. Okay. And this is where the absolute value of x came from. Okay. Now, what happens if you have this guy? Okay. The square root of x to the fourth. Well, x to the fourth is already going to be a positive value. That's x squared. Okay. And you can work this out more and more on your own. In the book, there are some examples. Okay, so let's do an example of something like this. It's a little more complicated, but it's a little more fun. All right, so we're doing example 2 on page 529. And that says, to simplify this guy, 40 x to the fourth, y to the fifth, z cubed. Yes, I know, it looks ugly, but we'll take it apart. All right. Now, remember, way over here, let's do some prime factoring. 40, 2, and 20. 2 and 10, 2 and 5. So we have 2 times 2 times 2 times 5. Okay, which is equal to 2 cubed times 5. So back over here, what we have is this, the square root, sorry about that, of 2 cubed times 5 times x to the 4th, y to the 5th, z cubed. Okay, well, now comes the nitty gritty. So we can break this down now into the square root of 2 squared times the square root of 2. That's where the 2 to the 3rd goes. Times the square root of 5. Okay, and then breaking this up times the square root of x to the 4th, which we already know, times the square root of y to the 4th times the square root of y. Y to the 4th times y is y to the 5th, yes? Okay. And last but not least, we have z's, which we can break up into z squared times the square root of z. And all we really did was take these elements under the radical sign and take them out and break them apart. Okay, so the square root of 2 squared is 2 times the square root of 2 is simply the square root of 2 times the square root of 5 times x. The square root of x to the 4th is x squared. The square root of y to the 4th is y squared times the square root of y times, now the square root of z squared is what? That's right. It's the absolute value of z times the square root of z. So combining all of this together, okay, we have, when you are combining expressions with radical signs, the radical signs come at the end, okay? And there's a reason for that. So look at how I arrange this answer. 2x squared y squared, absolute value of z, times the square root of 2 times 5 is 10, and we have a leftover y and z. Okay? And there is your answer. Okay? Okay, moving right along. What we have next is called the quotient property of square roots. And basically what this says is that if you have a square root of a quotient, okay, so say a over b, then what this equals is the square root of a, the numerator, over the square root of b, the denominator. All right? So for example, if you had the square root of, say, 49 over 4, then this becomes the square root of 49 over the square root of 4, which is 7 over 2. All right? That's called the quotient property of square roots. The next thing that we're going to learn about here is called rationalizing the denominator, which sounds scary, but it really isn't. Okay? It's rationalizing, the denominator. And basically, this is doing what you just learned about. And that means that any fraction that you have with a radical sign in the denominator, you have to get it out of the denominator in order for it to be considered in any kind of simplified form. All right, so for example, such as example 4 on page 530, part A, it says simplify this guy. So we have 10 over 3. Okay, so 10 square root of 10 over the square root of 3. This becomes the square root of 10 over the square root of 3. Now, just like with all other fractions, if you multiply something by 1, you haven't changed the value of the fraction, okay? So now this becomes the square root of 10 times the square root of 3 all over 3. And since the square root of 10 times the square root of 3, neither of those can be simplified, then you combine them. The square root of 30 over 3. This is called rationalizing the denominator. Okay. So, is it always this straightforward and easy? Not very likely. Now we're going to go back kind of into algebra land. And what we're going to find or look at right now are called conjugates. Okay, so conjugates are binomials that are in the form of this. So P times the square root of Q plus R times the square root of S, and P times the square root of Q minus R times the square root of S. These are called conjugates, okay? For example, the numbers are always usually easier to figure out. 3 plus the square root of 2 and 3 minus the square root of 2. These are conjugates. So if you multiply these together, okay, then you get the first, which is 3 times 3, minus the outer, which is 3 times the square root of 2, plus the inner, which is 3 times the square root of 2, times the last, which is the square root of 2 times the square root of 2, which becomes 2, right? So down here then, simplifying it, we have 9 minus 3 times the square root of 2 plus 3 times the square root of 2 cancels, and you have 9 minus 2 equals 7. I'll bet you weren't expecting a single value from all this junk. But there you have it. Okay, we're going to do example 5 on page 531. And that says simplify this guy. 2 over 6 minus the square root of 3. Okay, now obviously we have a radical in the denominator. We need to get that out. But if you simply multiply top and bottom by the square root of 3, yes, you'll clear out this radical 3, but then you'll add a radical 3 onto the 6. So you haven't improved your situation at all. That's why you need to use conjugates, okay? So using conjugates, then we have 2 over 6 minus the square root of 3, and we multiply that by the conjugate. Now remember, the conjugate isn't simply just the square root of 3 part. It's the whole thing. 6 plus the square root of 3 over 6 plus the square root of 3. So this whole thing equals 1. So we haven't done anything to the equation yet. All right, so distributing the 2 over this, I'm just going to rewrite this so that it becomes a little more obvious exactly what we're doing. Over 6 minus the square root of 3 times 6 plus the square root of 3. Okay, so we got that. Now we begin the distribution process. 2 times 6 is 12 plus 2 times the square root of 3. All over. What you end up with is 36 minus 3. So you have 12 plus 2 times the square root of 3 all over 33. As far as a fraction goes, that's as simplified as you can get. So that's its final form. All right. I believe that was the last. Yes, that was the last part of chapter 10, 10-1, I mean. So I'm going to wrap this up and get this video out to you guys. Thank you very much for listening. Hopefully this hasn't put you completely to sleep. And if you have any suggestions that I have control over, then I would love to hear them. You can submit them as comments under the YouTube video that you will be watching here. Okay? All right. Stay coronavirus free. Bye.